Okay, good afternoon, everyone.
Good afternoon, sir.
So today we will start with the new topic, which is beta function. Beta function and gamma ray function both are related to each other, so they have to be of the same type. And so we'll write down the definition. So consider the definite integral integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx, where m comma n both are greater than 0, is denoted by it is denoted by beta of m comma n, and it is read as the beta of m comma n is called the beta function and is called the beta function. So the definition of the beta function is like this. So whenever I write down beta of m comma n, this has to be equal to the integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. So this integral, I'll for just a re- I'm just recalling what was the gamma function. So gamma function was written like this, and we had integral 0 to infinity e to the power minus x raised to n minus 1 dx. So let's just relate both of them and see what difference do we have. The limits for the beta function are from 0 to 1, whereas for the gamma function, the limits were from 0 to infinity. Whereas the integrand for the beta function is x raised to m minus 1, 1 minus x raised to n minus 1. Whereas for the gamma function, e to the power minus x raised to n minus 1. Okay. So everything is going to be on the same lines, just like we define the beta function, then we'll go for the properties of beta function and so on. Okay. So before I go further, let me just tell you that again, beta function is an integration tool for finding out different integration. So we will write down the remark the way we have to use it. So whenever we will have an integration 0 to 1 x raised to m 1 minus x raised to n dx, then this is going to be beta of m plus 1 comma n plus 1. Okay. So every integration will convert to this form where we have variable raised to a number, 1 minus variable raised to another number, limits are from 0 to 1, and then we can write down the value as beta of m comma n. So the properties of beta function now. So the properties. First one, beta of m comma n is equal to the beta of n comma m. So if you look at the left hand side, what do we have? Integral 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. Whereas the RHS is actually integral 0 to 1 x raised to n minus 1, 1 minus x.
That's right.
Minus x raised to m minus 1 dx. So this property says that beta of m comma n is equal to beta of n comma m, which means that beta of 3 comma 2 has to be equal to beta of 2 comma 3. Okay, and for this purpose, we need to show that both of them are equal. So what possible change we can do here? I can put 1 minus x equal to t in this expression. So minus dx will become dt. If x is equal to 0, then t is equal to 1. And if x is equal to 1, then t is equal to 0. Let's substitute this in the expression. So what do we get? 1 to 0. The value of x is going to be 1 minus t raised to m minus 1. 1 minus x is t raised to n minus 1. Dx is minus dt. We change this minus and the limits of the integration. So this will be integration 0 to 1 t raised to n minus 1, 1 minus t raised to m minus 1 dt. So you can see that if you replace t by x, what you are going to get is beta of n comma m. So by the first property says that beta of m comma n is equal to beta of n comma m. The order doesn't affect the value of the beta function. First and very important property in some of the examples, this property will be used to show that the integrand is directly 0 because first one is beta of m comma n, the second one is beta of n comma m. Second, beta of m comma n is equal to 2 times integration 0 to pi by 2 sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta dp. This is what we have to show. Yes, anyone who can suggest some proper substitution in order to get this? What is beta of m comma n integral 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx? Yes, what substitution we can do here?
Square theta.
What you said?
Sine square theta.
Sine square theta, exactly. So if we put x is equal to sine square theta, so dx will become 2 times sine theta cos theta d theta. Change the limits. If x equal to 0, then theta turns out to be 0. If x
0
is
to pi
equal
by
to
2.
1, then theta turns out to be pi by 2. So after making the substitution, this turns out to be 0 to pi by 2 sine square. So that will be sine raised to 2m minus 2 theta. Please check the calculations. 1 minus sine square will become cos square. So this is cos raised to 2m minus 2 theta. The value of dx is sine theta cos theta d theta. So if you do the multiplication, sine raised to 2m minus 2 into sine theta, so that will be 0 to pi by 2 sine raised to 2m minus 1 theta. Similarly, cos raised to 2m minus 2 into this cos theta. That will be cos raised to 2n minus 1 theta, theta and 2 outside. So this is the one and the same expression. This expression is actually not used anywhere, but a version of this. So you can tell me now, if you have an integration 0 to pi by 2 sine raised to p theta cos raised to q theta d theta, what this will be equal to.
Half of beta p comma q.
Cos of, what did you said?
So beta of p comma q divided by 2.
Mm, no.
Sir, beta of p plus 1 by 2, comma q plus 1 by 2.
Exactly. Any other change?
Sorry, sir.
It is half correct. Something is missing. So the idea is we put p is equal to 2m minus 1 and q is equal to 2n minus 1. But there is this 2 outside which is multiplied, which you didn't
Yes, sir.
adjust.
Beta divided by 2 then.
So 1 by 2 beta of p plus 1 divided by 2 comma q plus 1 divided by. So what is the difference? We have just completed our reduction formula chapter, and there too we had this formula integral 0 to pi by 2 sine raised to m theta cos raised to n theta. Can you identify the difference there and here? What is the difference between these two? Okay, so what I will do is I'll do integration 0 to pi by 2 under root of sine theta into under root of cos theta d theta. Can you use the reduction formula here? In the reduction formula, the condition was these power was positive integer. Okay, in reduction formula. But here, even for under root, this can be used. Okay, there is not any condition on p and q. What is the value of p here? P is 1 by 2, q is 1 by 2. So the answer to this integration will be 1 by 2 beta of 1 by 2 plus 1 divided by 2 comma 1 by 2 plus 1 divided by 2. So when you have rational numbers as the power, you should go for beta. If it is an integer, you can solve by any of the ways, either by reduction or by beta. Okay, so the answer to this will be 1 by 2 beta of uh, 3 by 4 comma 3 by 4. Okay, so this answer you cannot get by reduction because in reduction we need integers. Fine. Next, and a very important property, the fourth one, says that integration 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n d. This value is nothing but beta of m comma n. So I'll rub this. The proof of this is this just depends on our substitution. In order to get the required thing, we make a proper substitution in order to get this. Again, this property is very important in solving a lot of examples. So integration 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx. So I will put x is equal to t upon 1 plus t. Look, there is no logic behind this. I mean, logic is I need to get this x raised to m minus 1 upon 1 plus x. That is the idea behind it. So in order to get that expression, I am making the substitution in that manner. So if you uh, start with this expression and think what I will have to substitute, so you will have to look at this term. You need to get this x upon 1 plus x. That's why we are substituting t upon 1 plus t. So if you simplify this, you'll get the value of t. So the value of t is x upon 1 minus x. The reason why I have done this is because when you put the value of x, you should get the value of t in order to change the limits. So from this, what is dx? Dx you will get using the u by v rule here, and by u by v rule will give me dt upon 1 plus t square. You can easily use the u by v rule. Now if x is equal to 0, then t turns out to be 0. If x is equal to 1, then you can see that t turns out to be infinity. You just have to put it over here. So what we get is integration 0 to infinity t upon 1 plus t raised to m minus 1. 1 minus t upon 1 plus t n minus 1. The value of dx is dt upon 1 plus t square. So this is integration 0 to infinity. So you can see that in the second one, t will get cancelled out and you have simply 1 upon 1 plus t. So minus 1 and plus 2. So denominator is going to be 1 plus t raised to m plus n. What will be the numerator? In this one, there is simply numerator as 1. So this won't contribute. This is simply t raised to m minus 1 dt. Look, t doesn't have a lot of role here. Which so what is playing a role is m and n. Okay, so I can simply put t is equal to x and I can get the required expression. So just this substitution is very much important. If you identify the substitution, you can get to the end. So for beta function, we have three different rules. Just a minute. This one, this one, this one. So by three ways, depending on our example, we can shift from which rule we need to use for the beta function. Of course, majorly the basic one which I wrote earlier as a definition will be used. All these are just the deductions from that rule. Fifth, a relation between gamma and beta. The rule says that beta of m comma n is equal to gamma of m gamma of n upon gamma of m plus n. A very important result which will give you answer for a lot of integrations. Just for purpose of an example, what I can do is evaluate the integral 0 to 1 x cube 1 minus x raised to 4 dx. What is this? What is this?
Beta 4 comma 5.
Beta of 4 comma 5, exactly. Beta of 4 comma 5. But by this property, the relation between gamma and beta, this is actually gamma of 4, gamma of 5 upon gamma of 4 plus 5. So what is this gamma of 4?
6.
There's 3 factorial, which is 6. Gamma of 5 is 4 factorial, which is 24, upon gamma of 9, which is 8 factorial. So this relation plays a major role to find out a numeric value for the given integration. The sixth property, gamma of p into gamma of 1 minus p. This property I should have given in the previous lecture itself, but no problem. Uh, this is equal to pi upon sine of p times pi. Okay. This property is important because in some examples you may get, say, 3 by 4 into gamma of 1 by 4. I want to find this. Look, when there is a 2 in the denominator, we can actually find out the answer by reducing it or increasing it, just like we did earlier for a gamma of 3 by 2. But in this case, you have 4. So reducing it won't help you at all. So other way is I can write this as 1 by 4 gamma of 1 minus 1 by 4. Moreover, here the condition is 0 is less than p is less than 1. If this condition holds, then and then only use this property. So this will be equal to pi upon sine 1 by 4 into pi. So sine pi by 4 is 1 upon root 2. So pi root 2. This is the answer. So this property is again very important, the sixth and the last property. Let's go for solving examples. Just a minute, I'll just give you one more property which is rarely used, but still it is very important as far as your MCQs are concerned. So the property says that integration 0 to 1 x raised to m minus 1 plus x raised to n minus 1 upon 1 plus x raised to m plus n dx. This is also equal to beta of m comma n. What was the previously used property? That was from 0 to infinity. X raised to m minus 1 upon 1 plus x raised to m plus n dx. This was also beta of m comma n. What is the difference? In this, you have limits from 0 to 1, and there is just one thing in the numerator, that is x raised to m minus 1 in the second one, whereas in this one, what we have, x raised to m minus 1 plus x raised to n minus 1. We won't go into the details of the proof, but please make a note of this. Example. Evaluate integral 0 to 1 x cube 1 minus root x raised to 5 t. Yes, anyone? What substitution we should make? No one? Yes. Yes.
Yes, sir.
Yes. What is the substitution we should make here?
So maybe root x
Yes. Root
equals to
x.
t, and we
Root
can write
x equals.
x cube as x square raised to 6
No, no.
something.
Why you want to put x
X
cube?
raised to x raised to 1 by 2 and whole raised to 6.
Why?
So then it will
Simply
be
put
again in the form of root
root.
x, right?
Look, what is our formula? Integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. We need to, I mean, align this example with this, and for that purpose we should put a root x equal to t. That's what you said earlier. Now this means that x has to be equal to t square, dx is equal to 2t dt. If x equal to 0, then t equal to 0. If x equal to 1, then t equal to 1. So what do we get here is integration 0 to 1 x is t square, so t square cube 1 minus t raised to 5, dx is 2t dt. Let's simplify this. So 2 coming outside, integration 0 to 1 t raised to 5 and this plus 1, so t raised to 6, 1 minus t raised to 5 dt. So this is 2 times beta of 2 times beta of Rohit. Rohit, Raj,
Sir, 5 comma 4.
5 comma 4.
7 comma 6.
7 comma 6. It is
6.
plus 1. So that will be 7 comma 6. So this is 2 times gamma of 7 gamma of 6 upon gamma of 13. You can do the further simplification, which is 6 factorial, 5 factorial upon 12 factorial. So cancel out the common terms. That is the way you can uh,
Sir,
1 upon 5, 1, 4, 8. The final.
sir,
Yes.
so the power of t should be 7.
Uh, Sorry. Gamma of 6. Gamma,
7.
gamma of 6. No, no, it is correct.
No, sir, power of t.
Sir,
Sir, you missed the 2t wala t.
no, no. Yes. Has to be 7. 7. So this will be 8. This will be gamma of 8. So this will be 7 factorial. But still the final answer is this. Can check it later. Fine. Next example. evaluate integration 3 to 7 x minus 3 raised to 1 by 4 into 7 minus x raised to 1 by 4 dx. Yes, any idea? So this is a special type. I will make a square and write it down. If you want, you can make a note of it. So when integration is from a to b, x minus a raised to m and b minus x raised to n dx. This type of integration is there, then put the substitution is x minus a is equal to b into t. Oh, sorry, x minus a is equal to b minus a into t. This is a standard thing. I mean, if you think on yourself for some time, you will understand why you are doing this. So, what will be the substitution here? X minus 3 is equal to 7 minus 3 into t, which is x minus 3 is equal to 4t. With that, dx will become 4 times dt. You can see that if you put x equal to 0, oh sorry, 3, then t turns out to be 0. If you put x is equal to 7, then t will turn out to be 1. So substituting this, we'll get integration 0 to 1. X minus 3 is equal to 4 raised to 1 by 4 into t raised to 1 by 4. What we will have, 7 minus the bracket 7 minus 4t plus 3 bracket complete raised to 1 by 4 into 4 times dt. So you can see that 7 minus 3 will turn out to be 4 and 4 I can take common. So 4 raised to 1 by 4 plus 1 by 4 plus 1. Please check the calculation. This is 4 raised to 1 by 4. Another 4 will come out of this bracket and there is this 4. Then integration 0 to 1 t raised to 1 by 4. The second bracket you will get 1 minus t over there and you have 1 by 4 dt. So this is 4 raised to 2 by 4, which is 1 by 2. This is 3 by 2. Integration 0. What is this? This is beta of 1 by 4 plus 1, comma 1 by 4 plus 1. 4 raised to 3 by 2, 2 cube, 8. Beta of 5 by 4, comma 5 by 4. So that will be gamma of 5 by 4, gamma of 5 by 4 upon gamma of 5 by 4 plus 5 by 4 is 5 by 2. Look, if there's a theory exam, you can stop over here. But if there is a MCQ based on this type of example, you surely have to simplify this in order to match your answer with the given option. So for that purpose, of course, I will simplify it over here. So 8 in the numerator, 5 by 4 is actually 1 plus 1 by 4, right? So what property I can use? 1 by 4 gamma of 1 by 4 into 1 by 4 gamma of 1 by 4. 5 by 2 is 1 plus 3 by 2. So this is 3 by 2. Gamma of 3 by 2 is again 1 by 2 gamma of 1 by 2. So we can simplify this ahead. So 4 and 1 4 will get cancelled out. This will turn out to be 2. So 2 upon 3. This gamma of half will turn out to be root pi. 1 by 4 we cannot do anything. So I will write this gamma of 1 by 4 square. Clear? Next example. Evaluate integration 0 to infinity x raised to 6 minus x raised to 3 upon 1 plus x cube raised to 5 into x square dx. So first of all, let's just multiply this x square. So this will be 0 to in. Okay, let it be x square. First of all, this formula looks similar to our beta function, which is integration 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx. This we saw that it is actually beta of m comma n. So in order to align this example with that, the substitution we need to make here is x cube equal to t. So 3x square dx will become dt. So x square dx is equal to dt by 3. You can see that if x equal to 0, then t turns out to be 0. If x is equal to infinity, then t turns out to be infinity. Put these values. So this will be integration 0 to infinity. X cube is t, so this will be t square. Please check the calculations. Minus t upon 1 plus t raised to 5. X square dx is dt divided by 3. I will write outside being constant. Let's simplify this. So I'll have 1 by 3 integration 0 to infinity t square upon 1 plus t raised to 5 dt minus 1 by 3 integration 0 to infinity t upon 1 plus t raised to 5 dt. Yes, anyone? What is the first term?
Beta of 3 comma 4.
3 comma
4.
3 comma 4. Look, this 2 is nothing but the t raised to 3 minus 1. And so depending on this m, you should adjust this 1 plus t raised to 3 plus 2 dt minus 1 by 3 0 to infinity t raised to 2 minus 1 upon 1 plus t raised to 2 plus 3 dt. So if you use the above formula, this one, by this what you get 1 by 3 beta of 3 comma
3,
2
2,
minus 1 by 3 beta of
2, 3.
2 3. So what is the answer?
0.
0, because beta of 3 comma 2 is equal to beta of 2 comma 3. So this type of MCQs can be asked like this. I mean, where easily you just have to use the formula properly. So evaluate integral 0 to infinity x raised to 8 1 minus x raised to 6 upon 1 plus x raised to 24. Do it. What is the answer? Anyone?
0.
Yes, exactly.
Zero.
Yes. So the next type of example is prove that integration 0 to infinity dx upon 1 plus x raised to 4 d. So in this 1 plus x raised to 4, of course, so whenever you see this type of thing, so x square is equal to tan theta. So 1 plus x square will which will be 1 plus tan square. So x square and things can be simplified later. So x square is equal to tan theta, which means that x is equal to under root of tan theta. Dx is equal to 1 by 2 tan raised to minus 1 by 2 theta sec square theta d theta. Also, if x equal to 0, then theta turns out to be 0. If x equal to infinity, then theta turns out to be pi by 2. Let's put this. So what do we get? Integral 0 to infinity, 0 to pi by 2. I've done a lot of mistakes here. So prove that this value is equal to pi by 2 root 2. Okay, so after substituting this, what do you get? 0 to pi by 2. 1 plus tan square, you will have sec square in the denominator dx will become 1 by 2 tan raised to minus 1 by 2 theta sec square theta d theta. This 2 gets cancelled out. So this is 1 by 2 integration 0 to pi by 2 tan theta is actually sine theta upon cos theta. So I can write this as sine raised to minus 1 by 2 theta into cos raised to 1 by 2 theta d theta. Any difficulty in this? No. So this is 1 by 2 beta of what's the formula here? 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. So 1 by 2 beta of minus 1 by 2 plus 1 divided by 2 comma 1 by 2 plus 1 divided by 2. This was the formula. You cannot use reduction over here. Please note this. So this is equal to 1 by 4 beta of 1 by 4 comma 3 by 4. What is the formula? 1 by 4 gamma of 1 by 4 into gamma of 3 by 4 upon gamma of 1 by 4 plus 3 by 4. See that the denominator is 1. So gamma of 1 is 1. What about the numerator? Yes, how can you find this? Anyone? No one?
Sir, gamma p into gamma
Yes.
1
Yes, gamma of p into gamma of 1 minus p. So this is the value of p here is 1 by 4. So the answer to this will be pi upon sine of p times pi by 4. So this is 1 by root 2. So pi by 2 root 2. So find that. Okay. Fine. One MCQ and that will be the end of this. Show that beta of m comma n is equal to beta of m comma n plus 1 plus beta of m plus 1 comma n. So let's consider the RHS and we will come to beta of m comma n. The RHS is beta of m comma n plus 1, so which is gamma of m into gamma of n plus 1 upon gamma of m plus n plus 1. This will be plus gamma of m plus 1 into gamma of n upon gamma of m plus n plus 1. Look, what we need beta of m comma n. I'll just write it down here. Gamma of m, gamma of n upon gamma of m plus n. This is what we need. Remember this. So in order to get that, what we can do here is I can write n plus 1 as n gamma n. Denominator is same, so I can simply add the numerator. So this will be m gamma m into gamma of n. And what is the denominator is same, so m plus n plus 1. So I can write this as m plus n gamma of m plus n. So any difficulty, please ask. So gamma of m, gamma of n common from the numerator, and what we get is m plus n. In the denominator, what we have m plus n gamma of m plus n. This two gets cancelled out. So what do we have? Gamma of m, gamma of n upon gamma of m plus n. So this is nothing but LHS. So that's all for the beta function. If you have any difficulty, please ask.
Sir, attendance.
Yes, what's it there?
Attendance link, sir.
Why do you want that?
Sir,
So
excuse me,
link
sir.
is, yes,
Sir, how is gamma 1 by 2 root pi?
gamma of 1 by 2 root pi, na? So
Yes.
use the, okay, thanks for recalling. I'll immediately give you the proof. I think so. You have integration 0 to pi by 2 sine raised to p theta to cos raised to q theta d theta. What is this? Uh, 1 by 2 beta of p plus 1 by 2 comma q plus 1 by 2. So what I will do is I'll put p equal to 0, q equal to 0. What do we get? Integration 0 to pi by 2 d theta.
Pi by 2.
And the right hand side is 1 by 2 beta of 1 by 2 comma 1 by 2. Right? So when you solve this, this will be pi by
Pi
2.
by 2.
The right hand side is gamma of half into gamma of half upon 1. These
Yes,
two get
yes.
cancelled out. So what do we have? Pi is equal to gamma of 1 by 2 square, which means that gamma of 1 by 2 is equal to under root pi. This is one way of showing that.
Okay, sir.
Yes, please mark your attendance. We'll stop here.